Another way of generating guesses, which we can check, which turns out to be very efficient. So here's some code that would do it. Again, I've got a little epsilon that tells me how close I want to get. Let's assume I'm looking for the square root of 24. We'll try some other examples in a second. I'm going to give an initial guess, which will just be y divided by 2. It's not a very good guess, but it's a reasonable place to go. And look at the code. Very crisp, very clean, very efficient. It basically says, check to see, am I close enough? Is the difference between the guess squared and y less than or equal to epsilon? If it's bigger than that, I'm not close enough. And then Newton says, get a new guess by taking the old value of guess, taking guess squared minus y, divide it by 2 guess, which is the derivative, and use that to create a new binding for guess. Just keep updating. Do that until I get close enough, and when I'm done, just print out the result. Nice and crisp. What's this doing? It's generating guesses. There's the generation. But it's not doing it exhaustively. It's using this property of mathematics to get it. And then it's testing right here to see if I'm done. So it's another example of a generate and test kind of algorithm. And let's look at what happens if we run it. So in my